Okay, so here we're going to show how to use Cut 2D to import a CAD drawing that has a lot of different parts, and what we need to do is take these parts and make pockets for them in closed cell foam for to put the parts in little compartments in a phone case. So the CAD file was a little on the complex side, probably had a lot more information in it than we needed. So what we're going to do is we're going to start here with a 12 by 12 inch piece of foam that's 2 inches thick. We're going to set our Z0 to the top of the foam, and we're going to put our center XY position, our start point, in the center of the foam, and we're going to leave it set to inches. So what we're going to do here is we are going to import vectors, and we're going to import in that file that had all of the parts to it. Now here it is here, and as you can see, there's an awful lot of parts there, and a lot more than are going to fit in this 12 by 12 space. So what we're going to do is we're going to select this whole thing, and we're going to move it out of the way. I don't want it in the border of the actual piece of foam. And just for the sake of a test here, just to show how we would set this, I'm going to take a few parts here. First thing we're going to do is get rid of the outside line because we don't need it. Then we're going to go ahead and select these 5 parts right here, and we're going to go to the Move, Select, Scale, Rotate tool, and we're just going to zoom out a little bit. We're going to move these parts over here into our work area. Now, as you can see, all we're going to do here with a CNC is we need to pocket around the perimeter of the outside. So none of these interior edges really mean anything to us. So before we get into that, first thing we're going to do is get rid of the numbers, because in this case the numbers are too small for us to CNC without a very, very tiny bit in there, and at that size bit, it's actually going to make it very difficult for you to read it in closed cell foam. So unless we make the letters larger, we're better off just getting rid of them for now and doing something else with labeling. So on this first component, the next thing we're going to do here is we don't need any of the interior hole dimensions. So we don't need any of these things here. But as you can see, if I were to click on this hole, you could see that I'm only getting a certain part of the vector. So these, when it imported, not all the vectors aren't linked together, so they're not closed, and it's a very simple thing to fix. All we need to do is highlight all the parts, go over here to this Join Open Vectors tool, set this to 1/1000th of an inch, and click Join. Now, when I click on this, you could see that it's highlighted all the way around. All the circles are. So we're going to highlight these and just hit the delete key and get rid of them. And we'll get rid of these and these here and these. And then if you zoom in here, there's one there and one here. So now we're starting to get there. Now we don't quite have the layout of the drawings that we need, because there's still this interior detail, and really all we need again is just the outside line. And as you can see, if I were to click on this, this part of the drawing is still separate from this part of the drawing. And so what we'll do is hold the Shift key, select them both, and we're going to just hit this Weld Selected Vectors. And you can see with a click of one button, it gets rid of all the interior, and all that I'm left with is the exterior outline, which is what I need. So we're going to go ahead and do that for these other objects here, and weld that one, and we're going to weld this one, and finally we are going to come back here and weld this first one. Now the first time I did this, I ran a test, and the first one gave me a little bit of was tricky for some reason, but hopefully, yeah, see, here it is. I'm not sure why it imported this way, but as you can see, it's still importing as 2 separate objects, and I don't really know why I did that, and the weld feature won't work. So what we are going to do here is go to Node Editing, and we're going to click on this line, and we are going to right click and do cut vector, and then we're going to delete this point. And as you can see, this line here now is gone. And we're going to go ahead and select this, and we're going to do the same thing on the circle. We're going to cut the vector, we're going to delete this point, and that opened it up. Now we're going to go to this cut tool, and I'm going to remove, I'm going to remove this vector, and I'm going to close it. Now I'm going to click on here, and I'm going to take this point, flip it around, and I want to get it to connect right. I want to connect this point to the end of the line right there. And now, as you can see, I've basically got the outline object, but you can see it's still set as two separate objects. So we're going to highlight them both, holding the shift key and clicking the mouse button, and we're going to go ahead now and click join open vectors. And now when I click it, we have one solid object that's the outline. Pretty straightforward. Not sure why that imported that way, but it was a quick fix to fix it nonetheless. Now the other thing I'm going to do is I want to arrange these parts in this piece of foam. Actually, you know what, before I do that, because this is a pretty good sized piece of foam, we can let's grab a couple more parts over from this side, and let's bring them in. Let's take these right here and these, and we're going to bring these over, and in here we're going to do the same thing. So what we want to do first is let's get rid of the numbers, just highlight them and delete them, and there should be one more. Here it is. Okay, now I'm going to zoom out a little bit. Let's zoom to object. Okay, so we're going to highlight these, and we're going to do the same thing. We're going to join all the open vectors, and that'll allow us to quickly come in and get rid of all of the circles, which we don't need, because again, we're just looking for the outside object. Okay, and now what we're going to do is highlight it and click weld, and it says there's at least two overlapping vectors. So when I click this, okay, let's try this one, see if weld works here. There, that one worked, and that one worked, and this one worked. So this one is giving us a hard time, just like the first one did. Not a problem. So we'll just go to node edit, and we're going to click on this line, and we're going to cut the vector, and we're going to delete the point. We're going to delete the point again, and we're going to cut this vector, and we're going to delete this point. So now when we select this, you could see we've got this object here and this object here, and when we click weld, now we have the outline. Perfect. Okay, so the one cool feature with Cut 2D Pro is the intelligent nesting feature. So what we're going to do now is we're going to select all of these objects, and we are going to nest them to have minimal waste in the work area. So we're going to click this button here, nest selected objects, and we're going to be using 1/8 inch tool diameter. I want to have a 1/4 inch piece of, actually let's do 1/2 inch. And the reason for that is you want to have a little bit of meat in the foam between the parts, so that when the bit is cutting, like if you had a really thin piece of foam like here between the parts, it's going to move when the cutter touches it, and you're going to end up with a less accurate cut. So what you want to do is you want to have a little bit of meat between the parts so that the foam doesn't move. It's got enough rigidity for that. And we're going to do the same thing. We're going to do a 1/2 inch border gap around the outside. We're going to rotate the parts to best fit. We're going to do this in 45-degree increments, so it's going to move in increments of 45 degrees to find the parts the best possible position to get in there. We're going to mirror parts we're not going to mirror the parts in this case, because this is the actual top view of each of these objects. So it's important that when we pocket out the foam, it has the same profile. So for instance, like this part here, if this was mirrored and it was flipped over, well, you would have to put the part in potentially upside down. Now, because I don't know what the actual parts look like in 3D, all I'm going to do here is make a pocket for it. So I want to assume that this, what we're looking at here, is going to be the top of the part. So that's how it's going to have to go in there. We don't want to allow the parts to fit inside other parts for obvious reasons. And then what we're going to do here, actually, I'm going to go back here. We're going to not rotate the parts. We're going to keep everything in the shape that it was in here. So in other words, I don't want to see this part kind of over here at an angle. Now, when this job is finally done, it may be that they may select certain parts to go into certain pieces of foam. I'm just trying to show you how to optimize this piece of foam right here. We're going to nest along the Y direction, and that's it. We're going to hit preview, and as you can see, it laid out these parts here, and it put these two on another piece of foam. So what we're going to do is go back, and we're going to do along Y and click preview. And the idea is we want to try to get all the parts into one piece. Now, if I go up here and did do the rotate and hit preview, you can see how all of those parts actually did fit in there. So if it doesn't matter to me what angle, you know, these are in, then, you know, we could certainly rotate the parts. But if it does matter, then, you know, we leave it alone. We want it to be like this. Now, in order to get this last one in, we have to look at, maybe we can shrink the border gap down to 0.4 of an inch and preview it, and that's still not enough. And maybe we can do the same thing with the clearance in between, and still not enough. So we're gonna go back here and let's try 0.3 for the border along the outside and preview, and we're still no joy. Let's go 0.3 here, and there we go. So now we got that last piece in there. The concern I have is, like I said before, I am a little concerned about how much space there is here to here. So when that cutter is coming around, you don't want this foam to move at all. So to be honest, I'd prefer that I had the 1/2 inch set there, and like I had before, and I am gonna rotate it because I don't mind if the parts are skewed. And as you can see, it's going to rotate it now, and then I know that the space between each part is going to be at least 1/2 inch. So that's kind of what I want. Now, it's okay that these parts are over in your workspace, outside the workspace. Nothing's going to happen to them. For now, all we're going to do is we're going to pocket out these parts. So to do that, what we're going to do now is we're going to click cancel here, and we are going to highlight everything so that it's dashed in purple. And we're going to go over to the toolpath tab, and we're going to pin that so that way it remains there. And we are going to hit the page up button, which is going to split this is going to give us a live view versus the drawing view. So our preview basically and our drawing. Now I just noticed we have one kind of erroneous little line there, and we want to get rid of that because that's not going to help us out much. What's going to happen is the tool, when it's pocketing, it's going to pocket around that line, and it's not going to look right. So we're going to go to Node Edit, and all we're going to do is click on this endpoint and delete it. And we are good to go. Perfect. Okay, so we're going to highlight everything again on this side, and we are going to come over here to Pocket Toolpath. We're going to have our start depth be 0, which is the top of the foam, and our cut depth, we want to cut all the way through the foam in this. So we're going to cut down 2 inches. We're going to select our end mill. In this case, we are going to use a 1/8 inch blue end mill. I already have it set for blue foam because we ran a test prior on that, so I know that these settings work really well. So we've got an 1/8 of an inch diameter bit. We're going to take 1/4 of an inch of material out per pass. We are going to run our end mill at 12,000 RPM, moving at a rate of 35 millimeters per second, and we have a plunge rate set at 25 millimeters per second. A plunge is the rate that the bit goes down into the material. Going to click OK. It's going to tell us that we're doing 8 passes. So to go through 2 inches, we're going to have to make 8 passes, which is correct. And then now what we have here is the 2 types of clearing the pocket. We have a offset, which basically clears in kind of a spiral manner, and then we have raster, which goes back and forth kind of like mowing a lawn, and then it makes a last pass to go all the way around. Now with foam, I like to use an offset. I like the tool to go around the perimeter and then kind of work its way in. I feel we get a better outside cut that way. We can change it so that you can go climb or conventional. I found that climb works really well, on at least on this blue foam that we had. You might have to test it differently depending on the foam that you have. We're not going to ramp plunge, and we're just going to click calculate. It's pretty straightforward. So in the preview window here, let's see. We could do preview all toolpaths, and you could see that's what we're left with. There's our piece of blue foam and you can see it cut through, and that's the pockets that we made based on the CAD drawing that we imported. So we imported a complex CAD drawing, we converted it to simple outlines, created a pocketing toolpath using an 1/8 inch foam end mill, and we are all set. That's what it's going to look like. It's perfect. So now the other thing that we're going to do is we are going to close this out, and we're going to select this toolpath here, and we're going to save it as a Mach 2/3 arcs, and we're just going to save that toolpath. We'll call it a foam test. And that's it. Now that foam test.txt file is what we would take over to our Stepcraft machine to cut this out. So once again, if we look at the preview everything, this is what we've got, and it is cut all the way through, which is what we want. It looks really good. Nice. So now those parts are going to drop right in that foam perfectly. And there you have it.